So if we take a day-to-day example, then we can see hello everyone, welcome back to PLUTUS STEM. Today we are going to discuss a very important topic, that is electromeric effect. So as we have already covered up the inductive effect, in which we have discussed how these electronegativity affect the sharing paired electron, how they are being pulled by the more electronegative atom and throughout the whole carbon chain. So now we will be seeing a different effect, that is electromeric effect. So in this electromeric effect, if this is our alkene and in presence of an electrophile, or you can say nucleophile, in presence of electrophile or nucleophile, if this electron pair, or you can say one sigma bond, one pi bond, the movement of the pi bond. So what is going to happen over here? One will have a positive charge and another moiety will have a negative charge. So this movement of positive charge, this movement of pi electron towards one carbon, the complete transfer, if it is being shown in presence of some reagent, then such effect is being termed as electromeric effect. So we will study it in quite detail. Firstly, we will be going through the what are the characteristics of this effect. So this is a temporary effect. It is a temporary effect. It comes into effect only when we are having a reagent, some electrophile or a nucleophile. It is a temporary effect. And you know, in the previous video we have discussed regarding the inductive effect. That inductive effect was a permanent effect. It was not being based on some incoming electrophile, nucleophile, or you can see reagent. And this effect is being shown by those substrates that are having double bond or triple bond. At least one double or triple bond must be present, or you can say a pi bond. At least the presence of pi bond is quite necessary, because the pi bond electrons are quite easily movable. They can be excited with ease as compared to the sigma bond. And we have seen this electron pair shifting was we were seeing in the sigma bond shifting in the inductive effect. And the third thing which we are going to see, it is a temporary effect. It is at least one double bond and triple bond is, and the third thing is presence of reagent. This effect is being shown only in presence of some reagent, or you can say electrophile or nucleophile. It can be electrophile or nucleophile. So these electromeric effect, can also be classified into two classes. These can be classified into two parts in the same way like we have discussed in the inductive effect, plus I and minus I. Here this electromeric effect will be represented as plus E and minus E. Plus E and minus E. Two type of effect are there, plus electromeric effect and minus E or minus electromeric effect. So firstly we will be seeing the plus E or positive electromeric effect. So in this type of effect, if we are having an alkene, reacting with an electrophile. If any electrophile is there in presence, if we bring some electrophile near this alkene, so what will happen? this alkene will change its electron pair. This electron pair will move like this. Because it is symmetric, this alkene is symmetric, so it can move either way, this side or another side. So if we are moving toward this, so this will have a negative charge and this one have a positive charge. So this type of movement of electron in presence of an electrophile is being termed as plus E or plus electromeric effect. So after that, what will happen? This electrophile will attack over here. A positive charge is being generated, which means the formation of carbocation. We can say carbocation formation. So for electromeric effect, you can learn that this electromeric effect, the movement of electron, the upcoming electrophile or upcoming reagent is being added at that side where pi electron moves. We are moving the pi electron at carbon number 2 and electrophile is also coming at carbon number 2. So the plus E effect is that effect in which the movement of electrophile this electrophile adds to that carbon on which the movement of pi electron takes place. Or in another word, we can say that these pi bond electron are being attached to the upcoming electrophile or the reagent. That reagent and that is being termed as the plus E effect. So if we take a day-to-day example, then we can see a alkene reactant with some acid. Reaction of alkene with some acid. So this type of reaction in presence of H positive, what is going to happen? This will move like this. Some negative charge over here and a positive charge over here. And this will be attacked by this H positive ion at this center and we will get a hydrogen. So this is one way, and one more thing which we need to consider, if we are having a asymmetric alkene, so then at which center we need to move the electron pair, we need to consider that we cannot move it onto the both sides, because if we follow both the pathway, so pathway 1 we are going to get CH3 single bond CH single bond CH2 negative and this one positive over here, and by another way we will be having CH3 CH negative and CH2 positive. So you can visualize that 2 degree carbocation is more stable and 1 degree anion is more stable, but here 1 degree anion is less stable and 2 degree anion is less stable and 1 degree cation is less stable. So this will not proceed due to the lesser stability. We will proceed through this pathway and after that the addition of H positive will take place to this center CH3 it will give rise to CH3 CH positive CH2 single bond hydrogen. So in this way this E plus or H positive can be shown, the electromeric effect plus E effect can be shown by this way for alkene, reaction of alkene with in presence of acid. So another reagent, another way is another part is minus I effect, minus E or electromeric effect. In this what we are going to see, it will show us the opposite what we were seeing in this. Let's say this C double bond O, if we are taking such type of reagent that will make us more clear vision of this minus I effect. So this is partial negative charge already, it will have a partial positive charge in presence of a reagent, or you can say nucleophile. What will happen over here? Here the movement of electron takes place. CO negative and positive. This nucleophile attacks at the center and we will have this nucleophile and O negative. So if you visualize over here, the addition of upcoming reagent or nucleophile to that carbon which is not having the electron pair, which is not having the pi electron pair, because pi electron is on the oxygen and this nucleophile is attacking at the carbon. In this case, at which position the electron pair was shifting, at that center this H was attacking or the reagent was attacking. So if both the things are on the same pathway, then it is being termed as plus E effect. And if the electron movement is on another atom and upcoming reagent is coming at the another position, so this type of effect is being termed as minus I effect. And here, if we take an example, then C double bond O can be reacted with Cn negative. So now how it can show the electron move like this, O negative and this positive, and this Cn negative can attack at this place and we get a product like this, O negative. So this is a minus E effect or minus electromeric effect. So we can visualize over here very clearly a very simple thing. Just the movement of electron takes place, movement of pi electron takes place in presence of a reagent, either electrophile and the nucleophile. Then this type of electron movement is being termed as electromeric effect. The necessary condition is that the presence of some reagent. If that reagent is being removed, then such effect is being returned back to its original position. So in presence of this nucleophile or electrophile, it exists in this way. But if we remove this electrophile or nucleophile or reagent, it will return back to its original stable form. So that's fast for your this electromeric effect. In the next video, we will discuss regarding the resonance effect and some other effects of these GOC. Thank you. Have a nice day.